Today's students looked at determining reasonable answers. And reasonable is a word that we're working with a lot this unit. Okay, the word reasonable means if I'm looking at a situation and I'm thinking about an answer that came along with it, does that answer make sense? Does it seem like it would fit in the situation? So we use the word reasonable a lot with students to help them when they're estimating, but also to help them when they're looking at an answer and thinking about that situation. Does it make sense? Is it reasonable that my answer got larger? Is it reasonable that my answer got smaller? Just to help them start thinking more about their actual answer, thinking about the question that they were answering, and really trying to make some connections about whether it makes sense or not. So you'll hear that word a lot come up in this unit, reasonable. So we're going to look at this example, and it says, write an equation to solve. We're going to solve an equation, and then we're also going to do an estimation. So it says, Danny works 16 hours, and he earns $148. How much does Annie earn per hour? Well, I don't know how much he earns per hour, but I know that after 16 hours at something, some sort of amount, he earns $148. So I know that this would mean 16 times something gives me that 148. Now I can go ahead and solve this equation, and this is similar to some of the problems that we've worked with area. When we're looking at, we have the area, we need to find the width or the length, doing the opposite operation. So I can't, if I were to sit here and try and figure out 16 times what? 16 times, I don't know, it would be really tricky. So instead of just trying to figure out what goes there, I need to do the opposite operation, and I can get there much quicker. So I'm going to take 148 divided by 16 to help me figure out what is that missing amount. How much is he making per hour? So 16 cannot go into 1, and 16 cannot go into 14. So I need to figure out how many times can 16 go into 148. Now, 16, if students are not very confident with what that number looks like or where to start, I always encourage them to start with a 5 because 5s are really quick and easy to multiply with, and it gives me a nice spot to decide whether I need to go up or go down with my multiplication. So 6 times 5 is 30, 5 times 1 is 5, plus 3 is 8. So I can see I need to go up quite a bit. So I'm going to hop all the way to 8. 6 times 8 is 48. 8 times 1 is 8, plus 4 is 12. Now, we always tell students to keep going all the way until you go over, and then you know that that one behind it is exactly what you want. So 6 times 9 is 54. 9 times 1 is 9, plus 5 is 14, and that gets me exactly what I want because it's as close to 148 without going over. If your student would have picked 8, they would need some coaching and going back and trying again to see if they could get even closer. So I've got 9 with 144. Okay, I'm going to subtract. 8 minus 4 is 4. And then I have zeros. Now because I'm working with money, I want to add a decimal, a 0, and I want to keep going. So I'm looking now for 16 times something to give me 40. Now 16 times 5 gave me 80, so I need to go lower than that. So I'm going to try 16 times 3. 3 times 6 is 18. 3 times 1, excuse me, is 3, plus 1 is 4. That's a little too much, so I'm going to go down to 2. 2 times 1 is 2, plus 1 is 3. So I have 2, which gives me 32, and I'm going to go ahead and subtract. 10 minus 2 is 8. 3 minus 3 is 0. Again, I need it to look like money. I want to know how much did he make per hour, so I'm going to drop down another 0 and keep going. Now, we encourage students, anytime that they're doing a long division problem, to keep all of their multiplication work off to the side. Don't erase it, because just like in this example, I have a problem that I actually did the very first time that I'm going to use for this problem. And I don't have to think about it again. I already did all of that hard work, and I can go and pull from it. So it's a good strategy to have them keep that work and also make them go back and look for which one would fit best. So here I'm looking for 80. I see over here in my work I've got 16 times 5 gives me exactly that. So I'm able to use that and find that he makes $9.25 an hour. So my x in this equation is $9.25. another thing that we've talked about for reasonable is to take that answer then and to really think, does that make sense? Does it make sense that $9.25 would be a reasonable amount to get paid? It would. And should it be smaller if I'm taking it times 16 to get a larger amount? Yes, it would. I don't want something really, really large or bigger than 148. That wouldn't be reasonable. That wouldn't make sense. So my 925 seems like a good answer. But another strategy that we've used to help them decide if they're on the right track is just to estimate. So instead of working with tricky numbers like 16 and 148, estimate those two numbers, round them to something that might be easier to work with. So for instance, 16 is really close to 15, 148 is really close to 150, and then this becomes a really easy problem for me to work with to decide if my answer seems about right if I try it this other way. 15 cannot go into 1, 15 can go into 15 though, one time. I subtract, bring down my 0. 15 cannot go into 0. If I added decimals here to make money, I would get zeros and then another 0. What I end up seeing is that would be about $10. $9.25 and $10 are very similar. So even when I estimated my numbers and was able to do that math much faster, I got a similar answer, which helps the student know that there were two different tries, they got a very similar answer, so they are on the right track. If you have any other questions about reasonable answers, estimation, or lesson 6.4, make sure to see your math teacher.